All right, back to it. Line of best fit, we're all good? So as I was saying, if there is a strong, hey girls and boys, students, people, if there's a strong linear correlation between the variables, the data can be modeled by the line of best fit. As you can see, this scatter diagram compares temperature and some costs. I don't remember where I grabbed it from to give you more details than that. But we've got a line, it goes through some of our points, and it's about even on each side, not quite exact. So we know what a line of best fit is, right? Now, here's how we draw our line of best fit. There's a few different steps. The first step is to calculate the mean of the x values and the y values. We did that yesterday when we were doing the correlation coefficient, so that shouldn't be too difficult for us. We can add up all the x's, divide by how many values there are, add up all the y's, divide by how many values they are. We do this, and then we actually put that point on our scatter diagram. So we add that point along with all of our original data points to our scatter diagram. So I think that's like the only thing that's really different from all those suggestions that you guys gave at the beginning of the notes that are no longer on the video because they were before the original one. But you guys said things like you just draw it in the middle, so we've got the same points on either side, you just draw your line. Well, we are going to put that mean point on the scatter diagram and then draw the line through that mean point. So it has to go through that mean point, and it has to fit the trend of the data. If you've got your data trending upwards, don't draw your line so it's trending downwards. I mean, you want to follow that. And again, make sure it's in the middle, so about the same amount of data points are above and below the line. So here is a scatter diagram again with the line of best fit. We can see that the mean point has been identified. It goes through the middle. There's about the same number of points on either side. So the whole reason why we do this is so that we can make predictions. So we could predict, looking at this, so this one we've got the ages and then we've got distance. And so our age in years, and I think this is like the throwing distance maybe of like a javelin, I think, something like that. But I can make a prediction, so like if a child is about 13 years old, so 13 is between 12 and 14, so if I go over and I could say, well then their distance should be about 22.5 meters. You see how we can use this to make a prediction? We're going to talk more about these predictions in section E when we talk about extrapolation and interpolation and kind of the reliability of how accurate these predictions are, but we'll get to that in a few days. The other thing we can do is we can actually write an equation for this line, like y equals mx plus b style. So we can calculate the slope, we can figure out the y-intercept and have our equation, which helps us then get a more accurate value rather than just estimating like I did. We could actually then plug 13 into the equation and figure out what we would get. Well, we're going to review how to write an equation of a line, even though that's something that you've done in Algebra 1. You should have done in geometry. And are you guys okay over there? It seems like something else is going on. javelin. Okay. All right. Anyhow, when we draw the line in, it's actually sort of called the line of best fit by eye because it's going to vary from person to person. Because we're all going to go through the mean, but we might have our slopes slightly different yet still in the middle. No two people should look exactly the same just because of like human error, right? So what do you think this means for when we check our answers in the back of the book? What was that? It might be a little bit different. Like, it shouldn't be way off. If they have a positive slope and you have a negative slope, like, something is wrong. But, it should be relatively close. So just keep that in mind that there are going to be differences. You might have answers slightly different. And I'll explain more about that when we go through the example. But just keep that in mind. So for the example, we're going to first calculate the slope, but we're going to use the same graph that we were just looking at. So as I was saying, after you draw your line of best fit, it's possible to find the equation of the line you have drawn. First, find the gradient, also known as slope, by identifying 2 points on your line and using the slope formula. And again, I realize it's been a while since you guys have spent time writing equations of lines. So remember that slope formula is y2 minus y1 divided by x2 minus x1, where x1, y1 and x2, y2 are just 2 points on our line. This one is not in your packet. I double checked last hour. So it's one of those that eventually you kind of have to commit to memory. It does look familiar though, yes? Okay. I would also say that one of your points should be the mean point. I haven't typed this up. Maybe this is something I should have written up there so you guys, see it, write it down. But either x1, y1 or x2, y2 should be the mean point because you calculated it, you drew your line through it, you know it's on the line. You drew your line through that point. So I would say always use the mean point. And then you might have to do some estimation on your second point, which is where some of the differences can come into play when we write our equation. So as I said, same graph as before. Find the slope. So the mean point is at 1529. I calculated that mean and we have it on the graph. So our mean point is at 1529. So we can say that is x1, y1. And then this is where the differences come into play, where if, depending on what point I choose that's like on this line, I might have slightly different slopes from other people, number one. Even if we had identical lines, if I chose different slopes and estimated slightly differently than you. And also, again, your line might be just a little bit different. So I'm going to pick the line, or the point, we're all going to do the same point. I'm going to say this one right here. So I'm going to say that that's at 1219. So I'm obviously estimating it's at 19. Maybe it's really at 19.3. Whatever. We're going to go with 1219 and say that that's x2, y2. So we can then find that slope by using the slope formula. So the slope formula is y2 minus y1. So 19 minus 29. And then x2 minus x1, so that's 12 minus 15. So we end up with negative 10 divided by negative 3, which is 10 thirds, because those negatives cancel out. Me, as a mathematician, personally, I prefer the fractions to the decimals. You will find most often either they're not as cute as this, or in the back of the book, they're using their decimals a lot. I don't think they use fractions like ever, so feel free to do what works for you. The fraction is about 3.33. The other thing about the back of the book, and I don't have an answer for this, I have no idea why, but it's like all of a sudden in chapter 21, they're like, you don't really need 3 sig figs. Just do do one, which just do the 3 sig figs still, okay? I don't want to change that on you. We've been hammering that into you all year. So just realize that when you look in the back of the book, your answers are going to be different, and they probably rounded it a little bit. I'm going to keep using 10/3 because who I am as a mathematician, but are there any questions before we go on to the rest of this and writing our equation of the line? Is this familiar to you? Did you guys need this review? I kind of feel like in my experience you guys do, but maybe you didn't. Alright, so then when it comes to writing the equation of a line, once you have the slope or the gradient, there are 2 methods you can use to finish writing the equation of a line. I don't care which one you use. I will say method 1 is the method that's used in the textbook. So if you're someone that likes looking at the examples in the textbook, they are using method 1 from what I can tell. And method 1 is my preferred method, and it's the way I like to teach my algebra students. But I never had you in algebra, so I don't know how you were taught originally. In my experience, most of my advanced students, like in this class, prefer method 2. So that's why I'm going to just go through them both, and then you can decide what works best for you. Method 1 would also be known as point slope form or point gradient form, depending on where you are, what you want to say. And for method 1, we'll put our slope value that we calculated on the previous screen in for the slope. And then I highly suggest using the mean point for your point. Don't use the other one you estimated. Use the mean point for your point. So our point will go in x1, y1. So I'll have y minus 29 equals 10/3 x minus 15. So any questions about where we have to put stuff? Then we're going to distribute the slope. So I have 10/3 x and 10/3 times 15 equals 50. That's kind of odd. Usually your y-intercepts turn out to be decimals as well. This particular problem, it's going to turn out to be a whole number. So once I add 29, y equals 10/3 x minus 21. And so again, like I was mentioning earlier, if I wanted to see like the distance of their average 13-year-old, how far they would throw it, I could just plug in 13 here. So I could do 10/3 times 13 and minus 21, 22.3. See, my estimate was 22.5. So a little bit different. Yes, still our estimate was close. All right. Any questions on the steps? So if you prefer this method, you end up putting your mean in for the x and y, and then you find b. So I have 29 equals 10/3 times 15. So when I multiply the slope and the x value, I end up getting 50. And then if I subtract 50, I end up getting b equals negative 21. We do have to take one more step and write it as an equation. So my slope, again, was still 10/3, so y equals 10/3 x minus 21. So it's really your call on what method you prefer. I like method 1 because I just have to do the problem and I get my answer. I don't have to take another step to like write out an equation. But that's just my preference. That's going to pretty much be it for the notes after the stat box. Are there questions? Are there concerns? All right. So stat box is a little bit of self-reflection. What method do you prefer? This is one of those things where, yes, you should have done this before, but you need to start to figure out what makes sense to you. Slope formula is not on, not in the packet, so it's something you have to memorize, but figure out what works best for you. And your assignment is 1 and 2. Now there is graphing because you're going to graph your scatter plot and draw a line. So if you want graph paper, I've got a stack and I've got more in my file over there. So that's sitting on my desk if you would like to use that graph paper.